friends, I am Banthiya from Banthiya's Training and Consultancy, and we are looking at the chapter Mole Concept and Stoichiometry. In this lecture number 4, we are going to look at a couple of problems based on mole concept and Avogadro's law. So let's start. So the question is, calculate the volume occupied by 3.5 grams of O2 gas at 27 degrees Celsius and 740 mm pressure. Here we already know that 27 degrees Celsius and 740 mm pressure are not pressures and temperature of s.t.p, but we don't know the volume at s.t.p as well. So first of all, let's calculate the volume occupied by O2 3.5 grams in s.t.p. So 1 mole of O2 at s.t.p will have 32 grams, which will occupy 22.4 liters, and we have to find the number of liters that will be occupied by 3.5 grams at s.t.p. Let's assume that to be x. So x will be 3.5 into 22.4 divided by 32, which comes out to be 2.45 liters, and this is at s.t.p. Now with this expression, that is P1 V1 by T1 equals to P2 V2 by T2, we can very easily calculate the volume at the given temperature and pressure. So let's start, and assuming P1 V1 and T1 be the pressure, volume and temperature at s.t.p. So at s.t.p 760 is assumed and volume is assumed. Volume is not assumed, volume is calculated as 2.45 by us, and temperature here is 273 Kelvin, which is equals to pressure that is given as 740 into X, that is the volume that we need to calculate at 27 degrees Celsius and 740 mm pressure, and 300 Kelvin, that is 27 degrees Celsius equals to 300 Kelvin. So now finding value for X, we get X equals to 2.76 liters, and this will be your final answer. Now let's see the next question. Calculate the moles of sodium hydroxide contained in 160 grams of it. All measures at s.t.p. So sodium hydroxide is NaOH, and let's calculate the gram molecular mass, that is 23 plus 16 plus 1. This will come down to 23 plus 17, that is 40. So 40 grams will be the gram molecular mass of NaOH, that is sodium hydroxide. Now we know 1 mole will contain 40 grams, and we have been asked how many moles will 160 gram occupy. So that becomes very easy. 160 by 40, which is 4 moles. So that's your final answer. Now let's look at the next question. Calculate the weight in grams of 2.5 moles of ethane. Ethane is C2H6. Let's first calculate the gram molecular mass of ethane, which will be 2 into 12 plus 6 into 1, which comes down to 24 plus 6, which is equals to 30 grams. Now we know that 1 mole will contain 30 grams. So 2.5 moles will contain how many grams? So X equals to 2.5 into 30, which comes down to 75 grams. And that's your final answer. Now let's look at the next question. Calculate the molecular weight of 2.6 grams of a gas which occupies 2.24 liters at 0 degrees Celsius and 760 mm Hg. Now 0 degrees Celsius and 760 mm is by default s.t.p. So you have been given that 2.6 gram of some molecule occupies 2.24 liters, and we know that gram molecular weight will occupy 22.4 liter. So this will give you the X. So X equals to 2.6 into 22.4 divided by 2.24, which gives 26 grams. That is, the molecular weight of this particular gas will be 26. Now let's look at the next question. Calculate the gram atoms in 46 grams of sodium, all measured at s.t.p. Now in the last session, that is lecture number 3, we have seen that gram atoms equals to weight of atoms, that is given divided by atomic weight. So we get the answer 46 divided by 23, which comes down to 2 gram atoms, and this will be your final answer. That's a very simple question, guys, and never miss this. Now let's look at the next question. Calculate the number of moles of KClO3 that will be required to give 6 moles of oxygen, all measures at s.t.p. Now KClO3, when it disintegrates, it forms KCl plus O2. Let's try and balance this. So we get 2, 2 and 3. Now what we want is 6 moles of oxygen, that is the common part, that is 1 part is equals to 2 moles. And so we will require 4 moles of KClO3, that is 2 into 2. That's a very easy question. Now let's look at the next question. Calculate the weight of substance if its molecular weight is 70 and in the gaseous form occupies 10 liters at 27 degrees Celsius and 700 mm pressure. This is an inverse of the first numerical that we have seen today. Here non-s.t.p volume is given and we are supposed to calculate the weight of the substance. So let's first try to find the volume of the given substance at s.t.p. So with this formula, P1V1 by T1 equals to P2V2 by T2. Here what we'll get, let's assume P1V1 by T1 equals to the pressure, volume and temperatures at s.t.p. So pressure at s.t.p is 760 into volume we don't know, and temperature is 273 Kelvin. 273 Kelvin, and the volume given to us is 10 liters into pressure is given 700 divided by temperature is given 300 Kelvin. Now let's find X, and X comes down to 8.38 liters. Now once we have got the volume of that gas at s.t.p, we know 1 mole it will occupy 70 grams, as the molecular weight is given 70 grams, and this will occupy 22.4 liters. But the volume occupied is 8.38 liters and we have to find the weight. So this will give 70 into 8.38 divided by 22.4, and when you simplify this we get 26.18 gram, which is the weight of the given substance. That's a tricky question, guys. If you haven't understood this, please go back and look at this solution again. Now let's look at the next question. The question is, state which of the following has higher number of moles, 5 gram of N2O or 5 grams of NO. Now 5 grams of N2O or 5 grams of NO is given. Now at s.t.p we know that 1 mole of N2O will contain 44 grams, and here 1 mole of NO will contain 30 grams. So by simple mathematical logic, we by default know that NO will contain more number of moles. You don't need to calculate the actual figures contained in 5 grams and 5 grams of N2O and NO. And if you do calculate, then you will come down to the same answer. So please pause this video right now and do that for yourself. Now let's look at the next question. State which of the following has highest mass, that is 1 mole of CO2 or 1 mole of CO. So 1 mole of CO2 will contain 44 grams and 1 mole of CO will contain 12 plus 16 is 28 grams. So obviously 1 mole of CO2 will contain more mass, that is higher mass. So the answer is CO2. Now let's look at the last question of this session. And I want you to pause this video right now and attempt this. This is again a very simple numerical. I hope guys that you have been able to solve this question. And if not, please comment in the comment section below and ask your doubts. Please let me know with the help of the card which is popping right now above the video that were you able to solve this question or not. So let's see the solution for this question. State which of the following has higher number of atoms, 1 gram of O2 or 1 gram of Cl2. Now first of all, let's see, 1 mole of O2 will contain 32 grams and 1 mole of Cl2 will contain 71 grams, and this will contain 6.022 into 10 raised to 23 molecules, and this will also contain 6.022 into 10 raised to 23 molecules. Now they are both diatomic, so we can say simply by looking at them that 32 grams is the molar mass and 1 gram is taken. So obviously it will contain more number of molecules as compared to fluorine, because its molar mass is 71 grams, which will again occupy the same amount of molecules, and hence the answer comes directly that O2 will contain more number of molecules. And if you really want to solve it again for practice, please pause this video and solve the numeric and get the answer, that is O2 has higher number of atoms in it. That's all for today guys. Thank you for watching this video, and in case you have any doubt, please comment in the comment section below. Please like, share and subscribe my channel, and please hit the bell icon so that you won't miss any updates from my channel. Thank you.